Drop it in chat. What is the test for kinetic energy? How do we know if an object has kinetic energy? Very nice. You can send me a private message so that you don't have to worry about being embarrassed or anything like that. Although if you get it wrong, that's okay too. This is called learning. You learn more when you get it wrong and then correct it. Oh, good stuff. I like your ideas. Nice. You're thinking. All right. So the test for kinetic energy is the object has to be in motion. If the object is moving, it has kinetic energy. The test for kinetic energy is the object has to be in motion. If the object's moving, it has kinetic energy. That's it. Okay? So we could talk about work and how it's connected and all that kind of stuff, but me as a person looking around the world at me, if I see an object moving, it has kinetic energy. Okay? Now, later on, what we're going to look at is a thing called heat and temperature, where even the microscopic particles that make up a substance actually have a component of motion, and that's the kinetic energy of that particle. And if we average the kinetic energy, we actually get the object's temperature in Kelvin. Degrees Fahrenheit and Celsius is not kinetic energy. It's an approximation, relative scale, complicated, but simple. Kelvin is actually a measure of the object's kinetic energy. So anyway, if it's moving, it has kinetic energy. Okay, so here's a trick question. You are sitting at your computer. You are not moving. If you were to stay still, do you have kinetic energy or not? How much kinetic energy do you have? If you're sitting still at your computer, so you are sitting at your computer, not moving, in chat. Do you have kinetic energy? Not to scale, of course. You're on your computer at a table, hopefully. If you are not moving, do you have kinetic energy? Ah, very nice, very good. So the short answer is your kinetic energy would be 0 joules. You have 0 kinetic energy if you're sitting still. Now, someone talked about if your fingers are typing, your fingers have kinetic energy, but overall, your whole body, if you're not moving, you don't have kinetic energy. I don't care if you're on top of Mount Everest, if you are sitting on the edge of a building looking over, you're really high up. If you're not moving, you have 0 kinetic energy. If you are not moving, you have 0 kinetic energy. Now, there's a caveat to that because we are looking at a set thing called a system. And when we say a system, we are looking at what we are observing. What do we observe? So you are not moving in relationship to the chair, to the table, and the computer near you. However, if I were to zoom out and look at the whole Earth, and you sitting in your chair, okay, are you moving now? Do you have kinetic energy? What do you think? Are you moving? Does the earth not rotate? Are you moving? The earth is rotating. So when we change the system, we change the context in which we are looking. You went from not moving to now you are moving. Okay, so you do have kinetic energy. Okay, let's change our system again. Now we've got the sun and we've got the earth. So we've got the sun and we've got the earth. Do you have a different amount of kinetic energy now? Absolutely, you do. So this is one of the peculiarities of physics, is talking about what system or observation are we actually talking about, okay? So in this system, you literally have zero kinetic energy, and that's the appropriate answer, okay? And that's the system we're going to refer to most of the time. However, if you zoom out and you change the system that you're looking at, then you might actually have a different answer for that, okay? This is actually, this system idea is also connected to this idea. Keep spelling it wrong. Reference frame. Reference frame. What's our frame of reference for what we're talking about? And a fancy way to say reference frame is context clues. What's the context of our observation? In this system, our context is just the room and the things around you. We're not considering outside factors, just the things inside what we're observing. Here, we're not considering outside factors. We're only considering the inside factors, okay? But it's different than this system. So they're not the same system, okay? That's gonna be huge next week. We're gonna talk a lot about this idea of the system next week, okay? Pretty cool and mind-boggling at the same time. This is actually where Einstein's theory of general relativity comes from, or deals with a lot, is who is the observer and what are they actually observing. And there is some things where it does not change no matter what reference frame you're in. So that's quite complicated, but we will not get into that. All right, questions? Bottom line, if the object is moving, it has kinetic energy. So if our system is just the room and it's not moving, zero kinetic energy, that's it. So don't overthink it, okay? All right, let's take a look at this. In Pear Deck. In Pear Deck. A, B, C, and D may or may not have kinetic energy. Tell me which ones have kinetic energy. There's more than one picture that has kinetic energy. And describe which one has kinetic energy and why you're saying that. Okay, someone's asking to re-summarize what I just said about the reference frame and all that stuff. Bottom line is, it's all about what are you actually observing and the context you're in. If you're only looking at the room you're in and that's your only context and you're not moving, then you have zero kinetic energy. That's it. If I change the context, what if you were sitting, okay, so you watch a movie and the guy's inside a little trailer, like on the back of a semi-truck. If you have the video camera inside the truck and you're just sitting there, you don't know you're moving. So you would say, I have zero kinetic energy relative to the system of the inside of the truck. If I cut to outside of the truck and you see the trailer truck moving and you know that that person's inside the truck, well, that person observes that that person is actually moving, but I changed the system, okay? I changed what the observation is. I changed the context, okay? So hopefully that clears it up a little bit. So in general, don't read into the context, don't read into the situation unless I ask you to. So in the future, if I ask you that question, you're sitting in a chair and do you have kinetic energy or not? You would say, I have zero kinetic energy because I'm not moving. End, period, end of sentence, end of question. If I ask the question, if I change reference frames, can you now change that? Then yes, then you would have to think differently, okay? All right. In Pear Deck, which ones and why? Okay, great, good. This can be a little difficult because they are still pictures, and so we are interpreting a picture as moving or not moving. Let's see. Good, good. Okay, still waiting for some responses in the Pear Deck. 7 people not answering in the Pear Deck. All right, about 30 more seconds. All right, let's take a look at some answers and talk about this. I'm going to pause you for a second. All right, letter B, because the Roadrunner and Coyote are actually moving, so they have kinetic energy. Letter C, it looks like the car is moving, kinetic energy. A and D both look like they're standing still, so no kinetic energy. And that's what this other person put as well. Now, that's absolutely true. Roadrunner is Roadrunner's running, Coyote's on a rocket, looks like they're moving. This race car, the background is blurred out, so it looks like it's moving. So those definitely look like they have kinetic energy. Letter A, Roadrunner and Coyote don't have kinetic energy, but the rocks are falling. So some people might have said that. You can maybe assume that they're falling and moving. So if they're moving, yes. I had one person talk about how the people in the background are probably moving, so they might have kinetic energy, even though the car does not. We don't know that for sure because it's a still picture. We can't see it, but if it was a video, that's probably what we would see. Okay, so once again, the test is it moving? It has kinetic energy. Keep it simple. All right, kinetic energy homework answers and questions. For the 7-step problems, here are the first 3 answers. And then for number 4, we're only talking about the bottom 4 questions. The bottom 4 questions. What did you put for number 4 on the bottom? The very last question. Put that in the Pear Deck. What did you put for number 4 on the very bottom? These are the answers to 4.3.3, the last 4 questions. If you are getting the answers wrong, make sure that you are substituting correctly and doing your algebra correctly. Mainly right now in the Pear Deck, I really want to see, what did you put for number 4? Ah, very good. Great question. Haha. That's because I'm being a Trixie Hobbitses. All right, let's. Very nice. Number 4 was very tricky. You actually could answer it without doing any math. Even though it was in the 7-step section, you didn't have to do any 7 steps. Ah, yes. Great explanation. I appreciate it. Good. All right. Somebody's already done this energy stuff before, so outstanding. Okay. So number 4, Mark is jumping up and down on a plyometric box. He does 1960 joules of work. What is his potential energy at the top of the box? What's his kinetic energy the split second before he lands on the ground again? So I jump up onto the box, and then I go back down to the ground. Then I jump. That's the exercise he's doing. He's jumping up on a box, hopping back down, jumping back up on the box, hopping back down. Okay. When he jumps, he does 1960 joules of work to get on top of the plyometric box. What's the maximum potential energy that he could possibly have? It's got to be 1960 joules. So he has 1960 joules of potential energy, because that's how much work was done. Now, if I have 1960 joules of potential energy, that means I have the ability to do that much work. So when I jump off the box, I have the ability in the future to do 1960 joules of work, and I'm going to do that. So when he hops down, he's going to do 1960 joules of work. When he hops off the box, which converts the potential energy into 1960 joules of kinetic energy right before he hits the ground. Because once he hits the ground, is he moving anymore? Nope, he stopped moving. No more energy. Okay, kinetic energy is 0. Okay, we're going to talk about what happens to that energy next week. No, wait, later this week, because it doesn't disappear. It turns into something else. Okay, so this is basically the underlying principle of work energy theorem and conservation of energy, but it's basically, I did 1960 joules of work and I got 1960 joules of potential energy, which I then did 1960 joules of work because of the potential energy and turned it into 1960 joules of kinetic energy. Now, what gets confusing or causes people problems is the number is the same for all of them, which is beautiful, and it allows us to do a lot of stuff mathematically. However, work and potential energy are not the same thing. They are very closely related. Okay, work creates energy, work turns into potential energy. Potential energy then does work, which creates kinetic energy. So they're all related, but they are not the same thing. Because I can have potential energy and not be moving. I can have potential energy and actually be moving as well. Okay. So I could have potential energy and kinetic energy at the same time. Okay. And be doing work at the same time. So each one of those pieces is a different thing, but they can turn into the other thing. Okay. So work is a force applied over a distance. Potential energy is based on your height above the ground because of gravity. And kinetic energy is, are you moving? Okay. So you got to keep those separate in your mind of what's actually happening, but the numerical values turn into the other thing. Okay. So the numbers will stay the same, but what's happening is different. We're going to jump into that big time next week. Okay. So next week, we will choose our third video. It's going to be open-ended. We are also going to spend part of our time next week talking about the evidence and what is good evidence, that kind of a thing. I think the second or third week of school, we talked a little bit about evidence, and then we never really got back to it like I wanted to. So we're going to spend some time analyzing our video number 1 and video number 2 for evidence, and talking about that and sharing some things out. So that's going to be next week with our quarter project. I will release the module overall. Just know that some of the information may be locked until later, closer to like progress report and after, because I don't want you doing something early and then getting a bad grade for it. Okay, because there are some specifics that we're going to be adding, but I hope to post a bunch of that information this weekend. So let's take a look in Canvas. Let's look at the quarter project for this week. Please make sure that when you click on the TED, talking about TED, that you go to File, make a copy, and Franklin TED number 2 overview. This is not the final document. This is pre-writing, okay? So make sure you realize that. So, and it looks similar to what we did last time, but it is different. So make sure you're using this document. Okay, you click OK, and now you have your own copy. And then you're gonna pick your video. Just know that this one will be talk number 2. Video list. I wound up deciding to keep it simple and use the same video list. I was gonna do a different one, but I decided to keep the same list as last time. You just have to pick a different video. So for example, if you did the physics of surfing last time, maybe you're gonna do what is the coldest thing in the world this time, which is cool because it's all about kinetic energy and absolute zero. We're gonna be talking about those later this week. So each one of these is something related to what we're gonna be talking about. The twin paradox is all about systems and frames of reference. Yeah, all of these things are going to be rooted in things we're going to talk about. Most of it we already have. There's a couple things that will come up in the coming weeks. So yeah, pick one of those and answer those questions. Just a reminder, these are like 1 to 2 sentence answers, okay? Later we will work on combining them into a paragraph, possibly, okay? So just be sure you read carefully and don't just assume what goes there is what goes there. Okay. All righty. Questions? Okay. You have about 8 minutes or so. It's not a lot of time, but you can be working on first answer the Pear Deck question. What's the difference between kinetic energy and potential energy? Once you've got that answered, then you can work on your quarter project number 2. You can work on tomorrow's video notes. You can work on yesterday's 7-step problems. Maybe you didn't get it finished, but work on one of those 3 things for me after you answer the Pear Deck question. Okay, there's no due date. I will put in a due date. I'm not going to count anything late or anything like that. The actual assignment itself, like the paper design and explanation of examples of potential energy and work, was due last Friday, I think. If you are actually going to build it and do the extra credit part of it, there is no due date set. It should be done before the quarter ends, which I believe is November 13, I think. So if you get it done before then you should be good to go on that. But yeah, I will fix that. Let's real briefly, I want to share with those of you that got D's and no marks for quarter 1, and I want to talk to you about how you can recover your grade. Okay, very simply, to recover credits, I want you to keep moving forward and not worry about quarter 1. There are so many things we are doing this quarter that you have to have paid attention and gotten from quarter 1, like 7-step problems. If you are struggling with that, that's something you should have learned in quarter 1. And we're going to keep doing it and adding to it. So that's one reason why we're all right, kicked me out and several other people out. Sorry about that. So to recover credit for quarter 1, in this quarter, you need to just focus on this quarter. If you get a 75% or better in quarter 2, I will change your quarter 1 grade to a 60% if you are one of the D's or no marks. If you get an 85% or better in quarter 2, I will change your grade to a 70%. The goal here is to keep you moving forward. If I tried to give you work from quarter 1 and you had to do quarter 2, you were already overwhelmed for quarter 1 and it just would be impossible for you. So I want you to keep moving forward. If you need to come to tutorials and get help, then you need to do that. Those of you that do have a D and no mark, expect an email from me with more details, because I am going to actually ask a couple things from you before the progress report to make sure that you are engaging and working on stuff. Okay, so I think that's reasonable and to get you back to speed. You do not want a D or a no mark. No marks are the equivalent of an F, which means you would have to retake the class in a normal world, and we are not in a normal world. So normally a no mark would mean you have to take summer school, you have to take the class over. We don't want to do that. You don't want to do that. So please get your Q2 stuff squared away, and you won't have to worry about it. Be taken care of, done. Some of you, though, also got Ds that normally would actually do better than that. You don't want a D, especially if you're college bound. You want to go to college. So, but you also want to just keep moving forward. A 70 is not the end of the world on your GPA. Promise me, I promise you, because I've been there. I've done that. And I went to the United States Air Force Academy for school, which was super highly competitive, and you can still make it work. So don't be discouraged. I know it's so hard if you are feeling discouraged about your grade and stuff. And if you have questions, please communicate with me. All right. With that said, let's go back to the Pear Deck. You have no more time. It is now student paced. You can now go back and answer anything in the Pear Deck. If you have questions, please stick around. Otherwise, have a great day. And I will see you on Thursday.